to help us be better readers, because you're not supposed to what? Skip anything when you're reading. And last time we were looking at everything. We were looking at tables and pictures and captions and diagrams, which kind of was helping us understand better about heredity. Okay, so let's remember to use this, okay, while we're reading today. Okay, let's go.
The standards that we are going to be using today are RI 1.1, refer to details and examples in a text explicitly and when drawing inferences. RI 1.3, explain events, procedures, ideas, or concepts in a scientific text based on a specific information in the text. And RI 3.7, which is interpret information presented visually, okay, like charts, graphs, diagrams, timelines, animations, and interactive elements on web pages, and explain how the information contributes to the understanding of the text. What will you be able to do by the end of this lesson? Well, you'll be able to explain concepts in a scientific text based on scientific information from the text, and you'll be able to use information presented visually to understand the text.
Okay, so the text that we were reading was Heredity, Pass It On by Rebecca Hirsch. Okay, so, and we left off on page 18 where they talked about the life cycle of flies. And they thought that flies came from rotten meat, but we learned that was not true because fly came from eggs, okay? So let's continue reading. Over time, people came to understand heredity better. Farmers learned they could cross or mate two kinds of sheep and create new sheep with thicker fur. Well, that's interesting. I didn't know that farmers could do that. Awesome. But the rules of heredity remain a mystery. People thought that traits blended like paints. Black paint mixed with white paint makes gray paint. People thought that a black cat father and a white cat mother would have gray kittens. Let's look at this picture and see if this is true. So black plus white, we all know that is gray. Look at that. So black plus cat, black plus white equals gray? There's a question mark. Does this say that this is true? It doesn't. It has a question mark. So we have to keep reading to see if this is true. But not all living things look like a blend of their parents. Sometimes a black cat and a white cat would have white kittens. How could this happen? No one knew. No one had solved the mystery. So we have, if we look at the picture, we have black cat that produced a white cat, a black cat and a gray, but the white also was able to produce the same thing. Let's continue. The monk in the garden. Gregor Mendel, a monk in Austria, wanted to understand heredity. He grew different kinds of pea plants in his garden. Some plants were tall and some were short. Some made white flowers and some made purple flowers. What would happen if he crossed or mated different pea plants? This is cool. And I can see here a white flower and then a purple with a little bit of white. I want to know more. Let's continue. Gregor crossed tall plants with short plants. He took pollen from the male part of a tall pea plant flower. He moved the pollen to the female part of a flower on a short pea plant. When he grew the baby plants, all of them were tall. None were short. The short trait had disappeared. He took a tall plant, a short plant, but they all still came out as a tall plant. I wonder why. Then Gregor crossed the baby pea plants with each other and grew more plants. Most of the new plants were tall, but one of every 4 plants was short. The short trait had come back. Interesting. So for every 4 plants, 3 were tall and 1 was short, even though he he used the baby pea plants with each other. Now there's a caption and a picture, so let's read it. Remember, it's important to not skip anything. So Gregory the scientist, as a monk, Gregory studied at the University of Vienna with some of the world's best scientists. His careful experiments require him to use a lot of math. So we all know that sometimes we have to use math in what? In science. Awesome. Gregory saw the same thing with other traits. He crossed pea plants that made purple flowers and pea plants that made white flowers. The result was all purple flowers. But if he crossed the new purple flowers to each other, about a fourth of the new plant made white flowers. Wow, that is super cool. The white trait had returned. So let's look, because I see here a little caption with a list. So maybe this is important for us to understand how Gregory did this. So Mendel's piece. Mendel studied 7 different traits in pea plants. Pea shape, round or wrinkle, pea color, green or yellow, pod shape, constricted or inflated, pod color, green or yellow, flower color, purple or white, plant size, tall or dwarf, which is short, position of flowers, middle or end of stem. He saw the same pattern of inheritance in all 7 traits. So Gregory realized the traits weren't blending. Instead, each trait was passed on whole, like a particle. You know that a particle is something tiny, okay? The tall parent passed on a particle for tallness. The short parent passed on a particle for shortness too. So that means that everybody gets both, but sometimes you get one more than the other? Maybe. Let's continue. Pea plant characteristics. So they have here traits, and they have all of the things that he studied. The stem length, the pod shape, the seed color, the flower position, the flower color, and the pod color. But I see 2 new words in this table. Dominant and recessive. Okay, so it says here that the dominant was the tall, inflated, round, yellow, middle of stem, purple, and green. And the recessive was short, constricted, wrinkled, green, end of stem, white, and yellow. I wonder what that means. Dominant and recessive. Let's continue reading. These particles are called genes. A baby pea plant inherits 1 gene from each plant. These particles are called genes. A baby pea plant inherits 1 gene from each parent. Every gene comes in different forms, the way crayons come in different colors. The gene for height comes in 2 forms, a tall form and a short form. But look at here. So these are genes, and each trait has a different color in the gene. So I see here that this represents eye color. I see that this represents hair color, and this one represents height. There's a caption. We need to read it. The different forms of a gene are called alleles. Individual alleles control the inheritance of traits. Some alleles are dominant, while other alleles are recessive. Ooh, I really want to know what dominant recessive means. Some traits are dominant, meaning strong. Finally, now I have a meaning for the word dominant. So dominant means strong. Other traits are recessive or weak. Okay, so dominant is strong and recessive is weak. So the dominant trait covers up the recessive one. When a baby pea plant inherits 1 gene for tallness and 1 for shortness, all the baby plants are tall because tallness is dominant. That is so interesting. Now, there is also another table here with a list, so let's look at it. Human genes. Dominant, dark hair, curly hair, brown eyes, widow's peak, dimples, unattached ears, freckles, and broad lips. Recessive genes, which we now know is weak. Light hair, straight hair, light color eyes, straight lines, no dimples, attached ears, no freckles, and thin lips. So, the father of heredity, George Mendel, published his ideas in 1866, but people did not notice his ideas were rediscovered in the 1900s, long after his death. Now he is considered the father of heredity, and there's a picture of him with his birth date and his death year. So this is really interesting, guys, but we're not done. We have a question to answer, which hopefully, looking at everything, pictures and text and captions and tables, is going to help us answer this question that we have today. So the first question is, choose the best reason that pictures of pea plants are included on page 18. So let's look back at page 18. And if you see, you have what? A picture of a tall plant, a short plant, and then it said that it equal all plants. So let's show the best reason why this was included. Was it A, to help the reader visualize the size differences of the pea plants in which Gregory was experimenting? B, to help the reader understand that pea plants were the only plant that Gregory could have chosen for his experiments. C, to show the purple and white flowers that grow on the pea plants. Or D, to show the different sizes of plants that Gregory grew in his garden. Yes, guys, that's right. The answer is A, that to help the reader visualize the size difference of the pea plants with which Gregory was experimenting. So now that I see which ones he put together, I can see that it didn't matter that he had a tall and a short plant. They all came out tall because of the dominant gene. Great. So here is your assignment for today, okay? And make sure that you submit this to your teacher either by calling her, or emailing, or texting her, however you communicate with her or him. Explain the best reason that the picture of pea plants are included on page 18, which we just answered, and explain why is it important to read everything, including tables and graphs in a scientific text. So make sure that you explain this to your teacher. Why is it important that we don't skip anything? How does that help us understand a scientific text? So again, guys, it's Wednesday. I hope you're checking in with your teachers. I can't wait to see you back next Monday. Enjoy the rest of your week and have a great weekend. Adios.